All right, so this is just a little worksheet going over 7.2. We've already gone over some of these problems or similar problems, but it's just good practice to go over it again. So this worksheet starts off with some of our basic definitions for sine, cosine, and tangent, and our standard triangle right here. This is how we orient our triangle. And again, it doesn't really matter how you do it, but it helps to be consistent so that you don't make mistakes. Here we have a little bit more definitions about the co-functions, right? Everything has a co-function: secant, cosecant, sine, cosine, so on and so forth. So let's go ahead and get started. This is relatively short. So for number one, find the values of the 6 trigonometric functions in the following triangle. So I don't like the way this is oriented, so I am going to reorient it. I'm going to put the right angle side where it normally is, and if that's the case, then that means that theta is here, and this side is going to be 6, and this side is going to be 8. So the 6 trigonometric functions means we want sine, cosine, tangent, and their co-functions. So first things first, what I'd like to do is try and find this c. So if we know that c squared equals a squared plus b squared, that implies that c is equal to the square root of a squared plus b squared. We'll go ahead and plug in our numbers and get that c is equal to the square root of 36 plus 64. That turns out to be a pretty nice number, and this is 10, right? Because 36 plus 64 is 100, square root of 100 is 10. So c is equal to 10. So if we know that sine theta is equal to the opposite over hypotenuse, well, the opposite is this 8 right here. So this is 8 over 10, which we could simplify to 4/5. We can do our cosine function. Cosine is the adjacent over the hypotenuse. So we have 6 over 10 is equal to 3/5. We know that the tangent function is the opposite over the adjacent. So we have 8 over 6. We can divide both of them by 2, and we get 4/3. Then we keep going and say that the secant theta is 1 over cosine theta. So it's equal to 5/3. The cosecant theta is equal to 1 over sine theta is equal to 5/4. And then the cotangent theta is equal to 1 over tangent theta, which is 3/4. And there you have it. These are all of the trigonometric functions for our little triangle. All right. So number 2, find the remaining values of the 6 trigonometric functions given cosine equals 1/2. So we're going to do the same thing. We're going to draw our triangle. So this is theta. Now cosine is equal to the adjacent over hypotenuse. So this means that the adjacent is 1 and the hypotenuse is 2. So we'll go ahead and call this C. We'll call this A, and now we're looking for B. So if c squared equals a squared plus b squared, that implies that b squared is equal to c squared minus a squared, meaning that b is equal to the square root of c squared minus a squared. So plugging this in, we get b equals the square root of 2 squared minus 1 squared, and this is the square root of 3. So I'm going to make this a little better here. We'll say that b is equal to the square root of 3. Fantastic. So from this, we can write the rest of our trig functions. I'm going to write them down here. So we'll start with sine. So sine is the opposite over the hypotenuse, opposite being root 3 over the hypotenuse. Cosine we already have. So we'll do tangent. Tangent theta is equal to the opposite over the adjacent. And the opposite in this case is root 3 over 1. Then we have the secant is equal to 1 over cosine, which I won't write. So this is just 2 over 1, which is just 2. We have the cosecant is equal to 1 over sine, is 2 over 3. Excuse me, 2 over square root 3. And then we have the cotangent theta. This is 1 over tangent, so this is 1 over root 3. And that gives us all of the remaining trig functions. All right, so in this way, if we know one trig function, we can figure all the rest out.
All right, so for this piece, what we're going to do is we are going to use the above triangle in order to show something that we actually already know. Right, we know from the identities that we did before that sine squared of anything plus cosine squared of anything equals 1. Let's go ahead and show that. So sine of theta is 3 square root of 3 over 2. Therefore, sine squared theta is equal to square root of 3 over 2 squared, which is equal to 3 over 4. Fantastic. So cosine of theta is equal to, it tells us up here that it's 1/2. So we're just going to go ahead and square both sides to get cosine squared theta equals 1/2 squared equals 1 over 4. So 3/4 plus 1/4 equals 1. And that is exactly what we expected. But this just goes to show that once we have actual values of sine theta and cosine theta, we can prove that. All right, so find the other two Pythagorean identities. So if you remember, we started with a squared plus b squared plus, equals c squared. This is a Pythagorean identity. And if we divide both sides by c squared, that's how you get sine squared plus cosine squared equals 1. But what happens if you divide both sides by a? Well, then you get a squared over a squared plus, or divide both sides by a squared plus b squared over a squared equals c squared over a squared. I'm going to rewrite this. So a squared over a squared is just 1 plus b over a squared equals c over a squared. Now b over a we actually know, don't we? We can remember our triangle, our standard triangle. This is our theta, this is our right angle, A, B, C. So what is b over a? Well, b over a is tangent. So this is 1 plus tangent squared theta. C over a we also know as secant squared theta. So that's one of them. We could do the same thing, but dividing by b squared. So you get a squared over b squared plus b squared over b squared equals c squared over b squared. And if you do that, you get a over b squared plus 1 equals c over b squared. Now a over b, we know that to be cotangent theta. So this is cotangent theta squared because it's c over b squared, or excuse me, a over b squared, and plus 1. And then c over b, well, we know c over b as cosecant squared theta. So the idea is that by starting with our Pythagorean theorem and dividing by a squared, b squared, and c squared, you end up getting all of the different identities. So you don't have to have all these memorized, you just have to know how to find them. All right, so number 5 and 6 we actually already, or 5a and 5b we actually already did, but we'll go ahead and run through it again really quickly. So we know that sine theta over cosine theta, well, that's how we define tangent theta. So this means that sine of 20 over cosine of 20 is actually equal to tangent of 20. So you end up with just tangent of 20 minus another tangent of 20, you get 0. All right. How about sine squared of pi over 12 plus 1 over secant squared of pi over 12? Well, if we remember, secant is 1 over cosine, so 1 over secant squared is just going to be cosine squared of pi over 12. Now remember that what's in the argument, right, what's in the parentheses isn't terribly important because you'll always get, I mean, so long as it's something that actually makes sense, you'll always get 1 because of our identity, so you get 1. Right? Sine squared of anything plus cosine squared of anything, so long as that anything makes sense, is always going to give you 1. All right, I hope this makes sense, and expect another one for 9.1.